We can paint the world a beautiful picture, holding out for everyone to view.
Welcome to math. We are working tonight on our second system of elimination of solving a system of equations, which is elimination. We did graphing before your midterm and practiced it a little, so now we can move on to elimination, and we'll do substitution tomorrow. Simultaneous equations, that's another word for a system of equations. They got you baffled? Relax, you can do it. Think of the adding or subtracting method, also known as elimination, of one of the variables to make your life easier. So our second method is solving a system of equations by what we call elimination. You may also see it being called addition or subtraction, or addition and subtraction with multiplication. So elimination does have some different names. To solve a system of equations with elimination, it's easiest when the equations are in standard form. So that, remember, ax plus by equals c. When the coefficients of one variable are the same or opposites, it's kind of a no-brainer, and you'll see what I mean by that in a few minutes. When the coefficients are not the same, then we multiply the equation all the way through so that I have similar coefficients. To solve a system of equations by elimination, here are your steps. Number 1, put the equations in standard form. Step number 2, determine which variable to eliminate. So you're going to look at the coefficient. If they have the same coefficient, then you will use that one. Multiply the equations if necessary and solve for the variable. And in this step, you're also going to multiply the equations and solve. That involves the addition and subtraction part there. Then you're going to plug back in to find the second variable, or third or fourth. And you always have to check because you may have done something wrong along the way. So you want to check in both equations, or if there's a system of 3 variables, you're going to check in all 3 equations. So let's take a look at how we would do this. Put the equations in standard form is our first step. But these equations are in standard form. All right, yay! Determine which variable to eliminate. So what you're looking at here is you want to basically add these equations together. Well, the easiest one to add together is if they have the same coefficient and it's opposite, because then I can just add the 2 equations and they're going to drop out. So the y's both have a coefficient. Well, they don't have the same coefficient. One's 1 and one's -1. But that means I can then add them instead of subtracting. So I'm going to add the 2 equations together. And that's going to eliminate the y. I'm going to get 4x equals 12 and then divide by 4 and I get x equals 3. So then I have to plug back in to find y. I'm going to plug in my 3 and I get y equals 2. Then I have to check in both equations. All right, so I'm going to relist my equations. First equation, second equation, good to go. You should show all of those steps. Okay, substitution we're doing tomorrow, so I'm not going to worry about that. All right, so put the equations in standard form. This is your second equation there, set of equations. They already are in standard form. Determine which variable to eliminate. You could do either. You're just trying to find the easiest. So the easiest are the variables that have the same or opposite coefficients. The x's both have a coefficient of 4. So in this case, I can subtract one of the equations from the other and they'll drop out. Okay? But you have to remember to subtract the whole thing. So it's -4x, positive 2y, and positive 2. That's going to give me 3y equals 9. And y equals 3. Solve the system using elimination. So I need to plug back in. I didn't solve the system yet. I only solved for y. So I want to find x, and you plug back in, and x is 1. Then you need to check the final solution in both equations. On your mark, get set, go. Tick tock, tick tock. You can pause. You should be done, and we're good. Maybe now it gets a little complicated. Teensy weensy bit complicated. They're in standard form, so that's fine. Determine which variable to eliminate. As you can see, neither variable has the same coefficient. Which one is easiest to get the same coefficient by multiplying through? That's what you're asking when you want to determine this. So I would say that it would probably, well, you can find the least common multiple. I'm not going to worry about that. You guys can do that mental math. All right, so to get a 2 would be the easiest. Otherwise, I would have to multiply this one through by 3 and the second one through by 2 to get a common coefficient of 6. Here, if I just multiply this entire second equation through by 2, I get a -2 there. So that's going to be easy. So I'm going to multiply through the entire equation by 2. And it should look like that. You should have the first equation. The second equation is 6x minus 2y equals 10. Then you can go ahead, add away, and solve for x. Now you need to go plug back in and solve for y. I'll let you guys pause here and do that. Come back and check your answer. Then you can also pause and check in the final equation. Moving on. Put the equations in standard form. They already are. So, which variable is easier to eliminate in number 4? I think that everyone would probably agree that it's the first equation multiplying through by 4, so I eliminate x's and solve for y in this case. So why don't you go ahead and pause here and try that? Okay, multiply the first equation through by 4, then determine if you're adding or subtracting, solve for y, plug back in, solve for x, and come back and check. Okay, so if you're back here, multiply the equation through by 4, or you could just do subtract the equations and you should get the same answer. I use subtraction. I don't multiply through by -4, but it really doesn't matter. Same thing. Okay, so x equals 3, y equals 1, and they do check. This is just a question we can go back and say, what's the first step? Determine, put the equations in standard form, then determine, then solve, go back, plug in, etc. Okay? All right, which variable in this case is easier to eliminate? Just a question here for you. Think about it, and I would say it is y. 6 and 4 are obviously not variables. Okay, number 5, pause, solve it, and you can come back and check your answer with. All right, in this case, it really didn't matter, obviously, which one you did. Either way, you have to multiply through by something that's going to give you an equivalent coefficient. So this one I would have to, depending on what I was solving for, I'd multiply through by 3 or 4, and the same thing in the bottom. So it really doesn't matter. I multiplied through the top by 3, the bottom by 4, and added them, and because one was an opposite sign, it was just a little bit easier. So it got x equals 1 and y equals -1, and it checks. All right, so you are on the back practicing, and I will give you the answers if you want to pause here and go ahead and solve the rest on your own.